Hello, flat earth researchers, debaters and debunkers. When it comes to the physics of gyroscopes, like those conventionally used in aircraft to keep the plane level and at a constant height above the surface of the earth, it is often claimed by defenders of the globe that gravity is pulling the gyroscope down and the gyroscope is therefore following the curvature of the earth, even though the gyroscope doesn't move. Well, let's hear what the physics professor Walter Lewin has to say about gyroscopes and whether that does or does not fit into the idea that gyroscopes will naturally follow the curvature of the alleged globe Earth.
So spin angular momentum has the property of stabilizing things. And you will see that addressed in one of your assignments when I want you to address that quantitatively. This is the basic idea behind inertial guidance systems. In inertial guidance systems you have a spinning wheel, at least in the days that the guidance systems had mechanical wheels. But that spinning wheel is mounted in such a way that you cannot put a torque on the axis of rotation of the spinning wheel. That's the way it's mounted. We call it three-axle gimbaled gyros. So the moment that you put a torque on it, the housings, in this case the yellow and the black housing, will start to rotate. And you never manage to get that torque on the spinning wheel. You never get it on this axis. And therefore, if now you put it on your boat or you put it in a plane, a missile for that matter, if you can never put a torque on the spinning wheel, and if the angular momentum for spin is in this direction, it will stay there forever and ever, assuming that we have no frictional losses. And if then the plane turns, the direction of the spin angular momentum will not change. But what will happen, of course, is that this yellow frame will rotate, or this black frame will rotate. And in these bearings here are shaft encoders. And they sense the rotation that the outer housing makes in order to keep this thing pointing at the same direction. And that signal is being fed back to the automatic pilot, and that keeps the plane flying in the direction that you want to. So you use as a reference all the time the spin angular momentum of your gyro, which is now mounted in such a way that you cannot put a torque on it even when the plane changes direction. And I want to show that to you.
So now he's going to spin up the gyroscope, just like the gyros in the artificial horizons of aircraft are spun up, while the aircraft is still on the ground before it takes off from the departure point. And as he said, to ensure that there is a reference point for the departure point, with the axis of rotation of the gyroscope remaining in the same position throughout the flight, no matter which way the aircraft goes, up, down, left, right, sideways, backwards, forwards. The gyroscope will remain pointing in precisely the same direction it was when it was spun up.
Okay, this is the direction of my spin angular momentum. And I'm the airplane. And I'm going to fly. Look at that spin angular momentum. It has no respect for me. It stays in the same direction no matter how I fly. And the error signals that come from the bearings of the yellow housing and the black housing, those arrow signals are fed back to the automatic pilot, and so the plane will stay on course. Now what I can do for you to come to a final test on your thinking, this wheel is suspended in such a way that there is no gravitational torque on it, like there was here. But I can put a torque on it by simply putting some weights on the axis. And what do you think will happen now if I put some weight here on the axis? So the wheel is spinning, but now I'm going to put a torque on it here. It is spinning in this direction. Angular momentum is pointing straight at me, away from you. I'm going to put a torque on like this, putting a weight there, Torque will be in this direction. What will the spin angular momentum do? Torque is in this direction, spin angular momentum is in this direction. Spin angular momentum will start to chase the torque. Watch it. There it goes. The spin angular momentum is chasing the torque. You see exactly the same thing that I've shown you before. And if I make the torque higher, then the precession frequency will go up. See, it stops now immediately when I take it off. Put it back on again. Continues. Put more on it. Goes way faster. What happens now if I put the weight on this side? So I change the direction of the torque. If I put it on this side, torque is now in this direction. Spin angular momentum is in this direction. It's going to reverse direction. There we go. And you see it does. Amazingly non-intuitive. If you have problems with this, you're not alone. See you Wednesday.
So there we had a demonstration of real physics with practical applications in the real world, which can only work above a flat, stationary Earth. They just would not work if the Earth was a spinning ball. Gyroscopes wouldn't be used because of the properties that they have. And as he said, it was amazingly non-intuitive when he added the weight or mass, because we would expect the increase of mass on one side to make the gimbal of the gyroscope point down towards the Earth. But because it was spinning and because gyroscopes always maintain the axis at which they were spun up at, the gimbal did not tilt. And so it becomes non-intuitive. And therefore, aircraft simply are not following any alleged curvature of the globe Earth when they are using gyroscopes to maintain level flight. Thank you very much.